Now that we have taken the case of y equal to kx, which passes through origin, as a special case, let's get into the next special case in case of the linear equations in two variables x and y. In this case being x and y. So let's see the case number 2 in the topic of the session. Now before we start with this, let's try to analyze what happens if the line is parallel to x-axis. There are chances of lines not always passing through origin or not passing through origin, but different cases where a line is exactly parallel to x-axis or a line is parallel exactly to y-axis. So let's go into investigating the cases of lines parallel to x-axis and parallel to y-axis accordingly. Line parallel to x-axis. So let's take the first case of a line parallel to x-axis. What would be the equation of a line parallel to x-axis is what is the investigation in the session, today's session. Let me take a Cartesian plane to investigate a line parallel to x-axis and its respective form. So I take the x-axis and the y-axis and the origin. Now let me take a line which is exactly parallel to x-axis. Parallel in the sense, any line I draw along the parallel to x-axis in the sense it is at equal distances at every pair of points. That is, when I take a line say I take the line this, which is assumed to be parallel to x-axis. Now this is parallel only when each of the distance as taken, the perpendicular distance between any 2 points on the two lines are equal. So imagine I take this distance and this distance. If they are equal, then I say the lines are parallel. Equally at distances, equally at equal distances. It cannot have unequal distance at any stage of its parallelity is how we understand parallel lines. Therefore, let me say the line L is parallel to x-axis. The line L is parallel to x-axis. This is the representation for parallel. So line L is parallel to x-axis. So let's see what would be its equation and its investigation. Imagine I have this line which cuts y-axis at k. So imagine that this line cuts y-axis at exactly the distance of k units. This is how I understand the distance of the line from x-axis to be k units. Now let's see what would be the equation of line. Now let me just take randomly any point out here. Say for example, I take the point P which cuts y-axis. P is the point where the line cuts x-axis. Point where, the line cuts y-axis. Point where L cuts y-axis. Therefore, the coordinates of P, because this is the y-intercept, simply because it cuts the y-axis, the line cuts the y-axis at the point P, P must be the y-intercept. If a line cuts x-axis, then that point will be the x-intercept. If the line cuts y-axis, then that point of intersection is called y-intercept. So P is the point where the line L cuts y-axis, as clearly seen out here in the diagram. Point where L cuts y-axis, which is 0, k, because the distance from O to P is k units, as can be seen clearly in this diagram. So this being k units, I have this to be 0, k is how we get the coordinates. Next, let me take the general form of the line, the general form of line L, which we know is represented in the form ax plus b. Or ax plus by plus c equal to 0 is how we get the general form. So let me take the general form ax plus by plus c equal to 0, where the condition, we know that a, b, c are real numbers and a and b are not equal to 0, is how we have discussed about the general equation of a line or linear equation in two variables x and y, which can be represented in its general form as ax plus by plus c equal to 0. Now, since this line passes through the point P, the coordinates of the point P must satisfy the given equation, is how we understand the representation of the line through the point 0, k. Therefore, P lies on L. Since P0k lies on line L, therefore this must satisfy the line L. Therefore, P satisfies line L. That is, the coordinates of the point P satisfy the line L. Let's see how we're going to satisfy the line through the coordinates. Now let's see the formula. What is the condition for the line L parallel to x-axis? So here comes the formula. Any line L, this line may be anywhere in the Cartesian plane, provided the condition that this line is parallel to x-axis. So any line L which is parallel to x-axis, here being the line L. So any line L which is parallel to x-axis is of the form y equal to k, is how I understand the formula, where k is the y-intercept, or k is the distance from the origin to the line L, or the distance of the point on x-axis, or the distance between the line L and x-axis. Therefore, any line parallel to x-axis must be of the form y equals k, k being the y-intercept, the point where the line cuts y-axis, the y-intercept. So this is how we derive the formula, where any line parallel to x-axis is of the form y equals k, understood in through the formula. Now let's see an example problem to identify the line which is parallel to x-axis through the given formula. Now let's see an example problem to understand the concept more better. The question here, which says, find the equation of the line which is parallel to x-axis and at a distance of 3 units below x-axis. Now here I have a question which has the various conditions taken into account. For example, the question here is find the equation of the line which is parallel to x-axis and which is at a distance of 3 units below x-axis. So let's see how we can identify the line through the given conditions. So before we do this problem, we need to analyze the given conditions through the Cartesian plane. Without the Cartesian plane and the display of this information on the Cartesian plane, it is impossible that we can solve this problem or any mathematical problem. Display the information in the Cartesian plane is the demanded condition out here. So let's see how we can convert this into the Cartesian plane. The Cartesian plane, which consists of x-axis and y-axis intersecting at origin, x dash and y dash intersecting at origin. Now the question says we had to find the equation of the line which is parallel to x-axis. The condition which we have seen in the previous session is about that any line which is parallel to x-axis is of the form y equals k. What's k? K is the y-intercept or the distance of k is the distance between the x-axis and the line, the perpendicular distance. So let's see which is the line which we need to find is said to be parallel to x-axis and at a distance of 3 units below x-axis. Now since the line is 3 units below x-axis, I obviously take the line below the x-axis. So as we take the scale 1, 2, 3, 4, 5 and 6, and then I have my scale here -1, -2, -4, and then I have 1, 2, 3, 4, -1, is how we get the scale taken as 1 centimeter equal to 1 unit. Now since the line is 3 units below x-axis and exactly parallel to x-axis, it moves 3 units down and I have a line which is out here. Which is like this. So here is the line which is parallel to x-axis and at a distance of 3 units from x-axis is how we understand below x-axis. Now, in order that we find the line, we know that any line which is parallel to x-axis, say this is the line L. So L parallel to x-axis implies y is equal to the line L can be expressed in the form y equals k, because any line parallel to x-axis is of the form y equals k. So this can be expressed as y equal to k, and k is the y-intercept. My k out here is the y-intercept. Now as I know my y-intercept out here is -3, therefore k is -3. As clearly seen, my line cuts y-axis at -3. So my value of y-intercept, that is k, is -3. Therefore, substituting k equal to -3 into this form, I get this to be y equals -3. Therefore, the equation which I demand for is y equals minus 3. Therefore, for the given question, the equation of the line which is parallel to x-axis and at a distance of 3 units below x-axis, with a distance of 3 units which is below x-axis, is y equals minus 3. Is how I conclude with the line parallel to x-axis.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.